And what that typically looks like is a huge stack of GPU racks furiously purring away in a data center somewhere. And the problems with this, guys, are numerous. One, it's really, really expensive, difficult, takes a lot of time and resources to train truly competitive models, which is why it has been something that belongs, until now, mostly in the hands of the well-funded and well-endowed institutions that currently control it. Secondly, the ownership part. If these guys are the only ones training it, they have a complete monopoly over the commodity that's produced when this thing reaches the critical mass that I think it's going to reach. And lastly, the barrier to entry as a result of this is just dizzyingly high. Modern training runs cost in excess of tens of millions of dollars, and this is such a perfect setting for something that BitTensor can tackle at scale, fully permissionless in a way that utilizes the decentralized network. So IOTA is something that we thought very carefully about for a long time. We've been doing incentivized training in BitTensor for about 1.5 years. We started with an older design, and one that we developed a lot. I think we was model becomes incredibly expensive, doesn't scale to this collaborative mechanism on top of what would have been much more expensive. And we drove that for a while. But really, we were confronted with the reality that a winner-takes-all competition, like the one that we used to operate, was simply just not the vehicle to get the scale and power of results that we think that we need. So IOTA is a radically different design, one that is distributed to its core. What this means is the miners are not all training a full model themselves. In fact, they're training a small fraction of a large model that is sharded across the network. And information flows between all the participants in the network so that this large model that is too expensive and too big to fit on any single node can be trained collaboratively across this harmonized network. So we pushed out a white paper on this quite hurriedly, actually, just before our release about 2 weeks ago. And we're quite proud of the work that we've done. This is a technical primer prior to release. We think that we made good progress on some of the hard problems. This is a really hard problem to solve. One of the hardest things about it is just how much data has to be exchanged when you're training really, really big models. We're talking about terabytes every hour. And that is just a massive bottleneck. And so the name of the game is compression. How do you just send as little data as possible by cleverly compactifying it into the smallest packages that you can? So as I previously mentioned, we've gone for a different architecture, which is called pipeline parallelism. You're going to see a little bit more about this in a minute. I'm trying to keep things not too technical, but I am guilty of going a bit too far.
We can return to that.
We can return to that. There will be questions after. So we've used this different architecture, which is the most modern expression of really how you can build a distributed training system. We employ data and pipeline parallelism. We also have incentives, which means that people that join the network, they don't just email in as an ask for permission. They can just sign themselves up, and you better believe it, they're going to do anything they can to make as much money as possible with as little effort as possible. And that is the adversarial nature of the beast. And we have had a hell of a week. So we went live on Monday last week, and our team have just been grinding day and night to get this thing stabilized. And we think we're getting to a point now where the first 15 bugs are squashed, and now we're doing things that resemble training rather than strange non-convergent exercises. So we're really proud of that. Another thing, of course, is we have made some really good progress on compression. This is something that we can go into later. I'm going to leave it there for now. We've thought very carefully about how we can exchange data as efficiently as possible, so send less data and send it smarter will be the picture there. And the last thing I'm going to touch on the white paper is a technique called CLASP that we developed that we think makes the measurement of the miner work as lightweight as it can possibly be by basically creating an auditing mechanism. So validators don't need to run all of the steps that the miners do to be absolutely sure that they've done something useful, but instead they can sort of passively scroll through a long database of actions that were taken because we have an orchestrator in our system. And that enables us to kind of get a God's eye view on all the activity in the network.
Is this Q the God's eye view?
This is Q the God's eye view. So we took a bit of a creative liberty when designing a dashboard for the subnet, and we went a little bit off the beaten trail. I think most subnets have dashboards. It's a great way to communicate the activity and the health and the productivity of a subnet. But we took quite a different view because there's such an interesting topology to the way that this network is structured. And you can see here, this is the IOTA dashboard. The first thing you see is this ominous cylinder that's a bit like a polytope. You can see that there's points. Those points are miners, and they're arranged in rings, which are layers of a large model. This is a 15 billion parameter model. What you can
Is this
also
live?
see, pardon?
Is this live? This is a demo video taken about an hour ago.
We didn't even think we'd be able to get the deck up.
You can access it on iota.microcosmos.
The loss is lower now. So also, yeah, taking you through this, you can step through the layers. You can see the mini competition that's taking place within the context of each layer in the model, because this is a competition. It's a productive exercise, but it's also a fierce competition. You can see which miners are the most successful in each layer. You can even drill down and look at individual miners in the system. Whether you are a miner or a hobbyist, you can explore the system in a way that's not really been possible before. So we're really excited about what this unlocks in terms of engagement, in terms of people being able to understand what the network's doing, and it's also kind of an educational tool. In addition to what we call the network view, we also have what's called the map view. The map view highlights the fact that this is distributed across the world. This isn't a data center. This is a global effort. And you can see here that we've basically got nodes that are scattered across different continents, exchanging these packets of data. And lastly, we've got the more familiar leaderboard view, where you can basically see the top performing miners, great for bragging rights, great for seeing if you're making money as a miner. And I'll leave the little demo right there.
So one of the things we found when we first started training on models on BitTensor was there were natural limitations to our architecture. And we spent last year pushing the architecture to its limits, working on data mixing, adversarial resistance, and all these small things. But we were always going to be limited by the parameter count. It's sort of, you have this resource inefficiency if one miner has to train it in absentia. So when we designed IOTA, we looked at how can we go not one step, but 2 steps forward. Not how can we move from 14 billion to 70 billion parameters, but how do we have a solution that can scale to 100 billion, 400 billion, or 1 trillion parameters, which is previously the province of only the largest labs in the world. So phase 1 of IOTA began this week. And honestly, guys, it's making it work. One of the joys of building on BitTensor is we had this thing working perfectly on testnet with our friends, VPN miners, and it's nice, and everyone plays nice. And we ship it to mainnet, and it's cool. And for the first hour, it works. And then it is brutally destroyed. And that which is destroyed becomes stronger. In the last 8 days, we've shipped over 30 updates to IOTA that have improved the stability, the communication protocol, the storage regime. We had a miner come to us yesterday and said they'd completely rewritten our mining code in C to get an advantage over someone else. And this is like the core philosophy of BitTensor, that the more competition you have, the better it gets. Like building on a whitelisted testnet is cool. We did it last week. It was great. It worked. You get to sleep when you build on a whitelisted testnet. You don't get to sleep on mainnet, guys. That's one of the joys of BitTensor and also its challenges. So phase 1 for this is making the system work and making sure it's doing what we want to do. Phase 2 is all about efficiency. We released the compression algorithm in our white paper. We have 2 more we're working on that we think can dramatically improve the performance, but also looking at how can we get all of you guys playing. One elegant solution of this system is you can take as many layers as you want. If you have an NVLink InfiniBand data center, you can take the whole model and participate in that way. If you have a MacBook at home, you can host a single layer and be paid in Tau in IOTA. So one of the ambitions for this subnet is not just to train big models, but train co-owned models trained at home. And we're going to be looking at that over the next few months. And finally, the point of this is scale. We want to go big. We don't want to train the best 70 billion parameter. And for those in the AI and ML space, you know that often great small models come from less great huge models. But IOTA is designed to build the biggest open source and best open source model ever. And that's our ambition with it. So a couple other points. a lot of people ask, like, oh, how do tokenized systems work with owning AI models and all these pieces? You can buy a part of this today, but in a longer term, we want to have ways to actually create value through this. So the first pathway is around building this frontier model. Anyone who participates, runs on their MacBook, buys an alpha token, can own this model, use it as much as they want for personal use. But in the same way that models that are said to be open, like Meta's open, you have to pay at a certain price. We can create licensing deals for larger stages. Secondarily to this, we have this thing we call a pathway 2, which we call cooperative training as a service. I will remember that. Now, I used to work in engineering and construction, and there's a lot of industries that do not have data centers worth of compute. They don't have the skill sets to train AI models and do algorithms. If you think of the hundreds and thousands of middleweight legal firms that have an immense amount of data and are at risk of being completely pushed out, we see an interesting opportunity to bring together groups of participants to pool resources, train a model, and either directly fund training through BitTensor or have interesting IP share agreements where maybe alpha holders fund the development but have a payback through. And these are the sorts of ideas that are not going to happen in the next 3 months, but in the longer term are areas we think can ultimately help this thing in the broader BitTensor ecosystem scale. So look, moving on a little bit from IOTA, because we're on a clock. Data Universe is another one of our subnets. We mentioned data being important. We have 34.8 billion rows of data in Data Universe today. We're actually using this data to train IOTA's models now. We're using rich transcript data from YouTube, high quality data from Reddit and X to fuel this thing. And as we expand data sources on Data Universe, we can use this to train our own and other models within the BitTensor ecosystem. But a big sort of challenge in the room and in crypto is how do you actually build products and services that are useful here? So Steph, if you cue this. Oh, it's loading. So we have a platform today called Constellation. You can go in, you can ask it to scrape as much data as you want. In this example, we're scraping Bitcoin and Ethereum use cases. And within minutes, you can load up, well, let's see how many it loads. This is obviously accelerated. Thousands of rows, tens of thousands of rows, millions of rows of data to help train your model, understand sentiment, or do other things. This is live now. You can log in, you can use this, you can pay for it. You can also visualize this through your own nebula. This is a data expression of how the data looks. You can search it, you can explore it, you can fine grain down to exactly what you want and use this to power agents, applications, predictions, and beyond. We also have built within Subnet 1, which Stefan's going to talk about, a native deep researcher taking advantage of test time compute. This uses all of the agentic tools and behaviors we've built into Subnet 1, web search, increasing tool usage. And what we basically do is ask the miners to be faster than this long, thoughtful response that the validator works with. It's a really powerful, is this looping? You can search by date. It's a really powerful tool. We're excited about the research direction around this. And I'm going to let Steph talk a little bit about Subnet 1.
Yeah, thanks. So let's get to the next slide. Here. So to build a deep researcher in BitTensor took a lot of deep research. What we want is to be able to build products that, again, don't just take the open source models off the shelf and host them. That's an enormously valuable commodity that we can provide. But the thing that we're obsessed with is how do we do better and how do we become leaders in open source AI? We've talked a little bit about training. We also care a lot about inference and agentic use cases. So what I'm going to share for a few minutes here, and I'm not going to get too technical. These guys are presumably going to have some questions. But I'm just going to keep this high level for now. We invented a new approach in Subnet 1, which we think solves a couple of really key issues when you have things like agentic intelligence contexts. So what if you want the miners to not just do exactly what they're told to in terms of, let's say I want to use a DeepSeek model, and I can verify that the miners used exactly that model, the right checkpoint, and it works. What if I want to get them to do something that goes above and beyond that? This is a modern paradigm which is called test time compute. Use more tokens, think for longer, use tools, search the web, do what you need to do, but just get me a great response. This is how you create the margin of improvement over things that you take off the shelf. So we came up with a structure around this where the validators play a very important role. They create what are called reference answers. The reference answer is the bar that is set. And the miners now have to produce something of similar quality to the reference answer. How does the validator produce a reference answer? It uses thousands of tokens. It searches the web. It uses code. It does everything it needs to. The net result is a model answer. Now, what we want to do is gamify this. So the miners are expected to do something similar, but in a fraction of the time. And this creates a really exciting asymmetry, because now you can stop articulating a competition where the miners have to do something that would take a standard approach an hour, but they have to do it in a minute. Think of what you can do with that. That's powerful. The second issue with that is now the miners are producing responses, and we know the validator has created a reference answer. We want those two to be as similar as possible. And that has been a problem that has plagued me personally for about 2 years. We tried 3 different versions of this in various iterations of Subnet 1, and you can rely on heuristics. Like, if you had 2 bodies of text and you wanted to look at how similar they were, you can do some basic things like, do they have a similar number of words? Do they have similar words? And as you get a little bit more sophisticated, you actually end up hitting a wall, which is just that text is inherently very fuzzy. It's very hard to measure similarity. The same is also sort of true with a lot of other modalities, but text is particularly subjective. You can have the same meaning, but have very different word choices, for example. So for a while, we explored something called cosine similarity, which is like, does the meaning of the text roughly correspond to the meaning of the reference answer? And we did this, and we got bullied by the miners over and over again. Half of them are probably in the room. So what we did with the architecture that allows us to do the deep research is we leaned into something that was very popular a little while ago in the deep learning community called GANs, or Generative Adversarial Networks. And this is interesting because it's 2 machine learning systems that train in tandem with each other. They train together, they train each other. One of them has to produce ever-improving outputs, while the other one has to guess whether or not a specific sample was the output from its neighbor model, or it was a true authentic sample, whether it's a real image and a fake image, or whether it's a text output by a miner and text output by a validator. And the exciting thing about this is it completely outsources this measurement problem, the fuzzy problem that was so difficult for us to get around. So these charts right here, after a rather long introduction, these charts basically show the progress of the network as it's learning right now, engaged in this game. One more thing I should add is it's a zero-sum game, which means that if someone guesses correctly, they steal points from the person that produced the output. So the 2 roles are the discriminator and the generator. The generator makes the outputs, the discriminator has to guess who made the output. And if one of them wins, the other one loses, which means that there's no way for anyone to work around this. So the blue curve basically shows that the discriminators, the guessers, were having a really easy time at the start. But you see this trend line going downwards. The reason the trend line goes downwards is because more convincing outputs from the generator are being produced. So the 2 systems are training each other, which is really exciting. And look, guys, I'll be the first to caveat. This is ongoing research. There's a long road. This is really rich. We're writing the paper for this right now. We think that there's a kernel of something really exciting here, not just for Subnet 1 and for Macrocosmos, but for BitTensor. We think this is an incentive mechanism primitive that we've sort of stumbled upon here. And I'm going to leave the technical talk there. That got so much more technical than I planned. Okay, you want to take this?
So look, finally, guys, and we probably don't have enough time to talk about this, but Mainframe as a subnet, we conceived of about a year ago, 18 months ago now. I lose track of time. And originally the objective of Mainframe was, can we fold proteins on BitTensor? And there was a talk and a panel I was on earlier where I think sometimes the early subnet months after revolution were a bit like the Wild West. It was like, can it be done here? And what we found out is BitTensor is actually really, really good at folding proteins. It was folding more proteins and faster than folding at home, the largest ever citizen compute project. Which is kind of amazing when you think this is one relatively small subnet within BitTensor. But what we realized going through that process with Mainframe and a bit more broadly was like, we need to find better product market fit for how this network is useful. So we spent a lot of time talking to customers in the pharma and the biomed and medical space and have moved Mainframe to being towards being a much more generalized scientific compute subnet that can provide capability, resources, compute to scientific researchers. And I guess it's a bit of a love thing for Stefan from when he was a physicist and couldn't get any GPUs. But we actually have a really promising collaboration with a group called Rowan Labs. We're creating data for them to train ML models for drug prediction. This is a commercial deal where revenue is flowing back into the subnet. And what's interesting about this and relates to the idea I mentioned earlier is they're part of a cohort of startups in the Boston area that are interested in co-funding access to compute. So again, this decentralized nature where they might all buy into training a much bigger data set to do something momentous aligns really nicely with the sort of ethos of BitTensor. We'll probably talk a little bit more about this on another day because we don't want to have too much content today, but lots of really exciting stuff going on there and very market-driven our work on this subnet. So look, I guess on this, we're working with a lot of teams within and without BitTensor, powering everything from predictions to supporting agents on shoots to enabling hours and other training examples. And we've spoken to people here about hopefully helping them train models in the future. But I suppose the final piece from us is you can access all of this yourself and use it, either through the front end, which you've seen, or just pip install Macrocosmos. I think that's us, guys. Thank you.
Thank you. All right, let's talk tech. Let's get into it.
Should we just send Will off stage and just be alone?
How do I pip install?
Alo and I are going.
Let's just break out and talk about generative models. Sometimes, when I'm talking to teams in BitTensor, I realize like we're on a fusion rocket flying through space, trying to like capture the fusion reaction exploding, and you guys. I told you a little while ago, I was like, I think you should write a research paper on IOTA. And you're like, okay, let's do it. But honestly, there's so many papers that we could have written about all of the different things that we've tried. Oh yeah, cosine similarity. It's this good, it doesn't work. You go invent GANs, there's a research paper there. But we're moving so fast that we often don't have time to just stop and like write about it, like write it down. And we're getting to that point now. It's actually happening. And so novelty search has actually been just like the only place that these ideas have been talked about. And that's why I ask these tech questions, because they're not in research papers. Like this is us actually generating research papers every single Thursday about the absolutely incredible work that you guys have been doing. Like the fact that we have basically taken generative adversarial neural networks and made them incentivized, and nobody knows about that is kind of insane, because GANs are, we just invented a completely new stack, and we're moving so fast in this stack that we don't even have time to like, okay, well here's like a standard NN, like this is the MLP. We're already at GANs and we haven't written a research paper, and so that's why I do want to jump into the tech here. You guys are really the first team on BitTensor that really got this idea of the multi-subnet, where each subnet is a product of other subnets and they work together. Pre-training and Dataverse, they make a lot of sense, right? You guys want tons of data, high quality data, and we don't want to pay somebody else, we want it in-house. And so we have Dataverse and IOTA are like obvious customers for each other. You're reaching out to that pinnacle element. And then, test time compute, reinforcement learning, taking these models that we're pre-training and fine-tuning them. You have the full stack, from data to pre-training to fine-tuning, and perhaps you'll do an inference subnet as well at some point, but maybe we don't need to do that. That's pretty much solved. Let's go, which one should we go into first? Because I think that it's worth, there's a lot of people in the crowd that are actually building subnets that that might be interested, or at least I'm always just super interested in how these things work. And I had a 20-minute keynote earlier. I didn't have any time to talk about like what the hell BitTensor is, actually, like how does BitTensor work, right? So what these guys are talking about, to those that don't know, is they're talking about the construction of a validation mechanism. They're writing a Python script which describes how you measure something and how good it is and how fast it is, whatever it is that needs to be measured. You get very specific about it, you write it in a Python file, and you launch it into a network. And the reason why this becomes so difficult to wield is that the miners read your validator script and figure out a way of getting around it, right? You know, in early neural network research, they tried to use multi-level perceptrons. They didn't work. We didn't have activation functions. They were just unwieldy. We took the field from the MLP in the 1950s all the way into 2008 before we ever got AlexNet and were able to train large language models and large neural networks, like deep neural networks. I think that a similar kind of progression is occurring on BitTensor. We have this fusion reaction. We know this thing is explosive, but how do we really get it to work? You guys are getting things really working now, which is fantastic to see. Let's talk IOTA. You're right when you said it. Like we've been focusing on that problem in BitTensor for a very long time, because we know that the ability to train state-of-the-art, extremely large language models in a distributed setting is really the only thing that will take us to a world where we can ensure that resource, these foundation models, are like co-owned and co-contributed to. So there's like a billion problems you guys had to solve in order to make this happen. Let's just talk about like one. Take us through a day, Stefan, of like how you think about building this incentive mechanism and all the complexities involved.
Yeah. Okay. So one of the key differences between IOTA and what currently exists both within and without BitTensor is the idea of pipeline parallelism. And that introduces a whole new dimension of complexity. So data parallelism is every miner or every peer on a network has a full copy of the model. And they're going to train their copy of the model, and then periodically they're going to share information so that they can benefit from the learning of the entire group, and they're not just an island. And this requires a very complex synchronization process that has great strides of progress have been made on that by teams like News Research, Prime Intellect. Those guys are cracked. It's been great. However, pipeline parallel is, in many ways, I think it's kind of the North Star, because pipeline parallelism lets you blow the lid off this thing. With data parallelism, every miner needs to be able to run the hardware to run an entire copy of the model. So for a 30 billion parameter model, I'm not going to get too much into the billions of parameter counts here, but to run even a medium-sized model, we're talking that miners need really serious gear, really serious first generation, like really powerful machines, and lots of them. And this just creates a barrier to entry. And at some point, it starts to undermine the idea of, well, what do we mean when we say decentralized, if it's just 16 people that can afford to participate? And of course, there's clever things that are being done here. This is a very nascent field, I would say. So let's not judge any of this based on what we know today. I think in 5 years from now, we'll look back and we'll laugh and we'll say that was inevitable or that was obvious. But data parallelism means, as I mentioned earlier, that you split this big model up into small models. Now you've got these bite-sized chunks that each miner can operate independently. This means the barrier to entry, as Will alluded to, is eventually it's a MacBook Pro. It's consumer hardware. That's the dream. Reaching the scale means tapping into this massive network of potential participants. And for that reason, you can't depend on them all having hundreds and hundreds of gigabytes of VRAM.
Should we just call the app Tower at Home?
Tower at Home.
I mean, that was so bad. I think you should get off the stage. I'm just saying. Okay, so what I would like to see is kind of take a bit of a step back here. And I think maybe I like kind of polling the crowd. Has anybody here read the IOTA white paper at all? All right, maybe that's like 5%. Can you kind of, you've got your validators, you've got your miners. Let's assume everybody's being honest and everything's cracked and you're good to go. How do you go about orchestrating all of this? I think that's very important to kind of explain that a little bit intuitively.
Yeah, this was a really consequential decision. So there were two options. We could do pure peer-to-peer. So miners communicate with each other directly. It makes it quite hard for the validator to be embedded in the system in a way where it can really monitor the performance of the network, because the miners have direct access to each other. You can have collusion. You can have all kinds of additional attack vectors that are really, really hard to keep pace with. The alternative is you have more of a hub and spoke design. So you have a central entity, either for storage or compute or just doing the bookkeeping, making sure they know who's assigned to which layer, who's working on which job right now. And the hub and spoke mechanism for us was kind of a no-brainer in the end. And the reason for that is because we get the benefit of having a God's eye view of the whole network. So while it's maybe not the most purely decentralized, it's just a vapor of peers without any central point. At least in this bootstrapping phase, it gives us a way to learn from the system in flight as it's training, as attacks are happening. So the orchestrator is a central component. Basically, when miners join the network, they register themselves with the orchestrator. They're assigned a random layer. And then from that point onwards, we're off to the races, and the orchestrator is randomly assigning miners in each layer data. Because the miners are arranged into this layer-wise structure, a sample needs to propagate all the way down the model and then all the way back before the learning signal is ready to be trained on. So we have to make sure that the orchestrator has the map, the global map of movement of data, and it's a very complex thing. And in fact, this is the thing that we've been stabilizing for the first week. It was much more complex, especially when we get a midnight DDoS attack the night before Novelty Search. It's stressful stuff, but we survived.
Sorry.
I guess it's important again to these are the realities of building on BitTensor, guys. It's it's competitive. That somebody felt like trying to take down the system last night, and they can't do it anymore because we've solved that problem. And all of these challenges you go through in building a subnet, and to the owners in the room who are thinking of this, you're going to find an exploit you didn't believe possible. They're going to attack you in a way you didn't know, but it all makes the system stronger in the long run. More trustless, less focused, less risk averse.
Yeah,
And these are the core ingredients of BitTensor.
in machine learning research, you'll come up with an architecture that you want to try. You're like, okay, we're going to do a mixtures of experts model. We're going to train on these features, and we're going to train for this long with batch size and learning rate, and you tune a bunch of parameters, and you don't know beforehand if it's going to work at all. Like if you knew before you ran the experiment, you wouldn't have to do it. You just search the hyperparameter space. It's very similar with incentive mechanisms. And I think people don't really understand that when they first come. They're like, okay, I'm going to design the incentive mechanism and make it, and obviously try to make a good experiment. But you just kind of don't know until it's red teamed by a distributed global 24/7 group of fuckheads that if it's going to work. And so you what really matters is and sorry, miners, I love you guys.
A little too late there.
Most of us are in the room.
You know who you are, and you just don't know until you run the experiment. And so I think one of the great things that we do in BitTensor is we test in production. We just test in production over and over and over and over again, because you need to run these experiments. You don't know if they're going to work beforehand, and that's why it's such a terrible job, and that's why your hair is graying. And these guys, it's really, really, really hard work what you guys do. We were talking 2 months ago, and I was like, we should just launch it tomorrow, and you're like, please give me 2 weeks, and I was like, no, tomorrow. I think it was good that you waited that amount of time. But now that you're in the thick of it, you guys have iterated on this design maybe 12 times.
Absolutely.
Yeah, right. So you've done 12 experiments where somebody that's trying to do this exact same thing, that's thinking about launching a protocol, okay, you're not even at iteration 0. We're at iteration 12 now, right? In a week, right? And that iteration speed is what I think has allowed us to go really fast. And what really makes BitTensor good to build on is how quickly we can change the protocol and how many experiments we can run. So you guys know all about that.
YOLO coding.
YOLO coding.
So,
Vibe
about
incentive
this
mechanisms.
Orchestrator, is this incentivized or not?
This is incentivized.
The orchestrator itself is it a miner or a validator?
No, not the orchestrator isn't incentivized. The network.
It's a messaging broker more than anything else.
That's all it is. So it's not an actual existing machine.
The
that has to
validation
coordinate
is
stuff.
performed on the validators themselves, and the orchestrator just serves as a communication layer for storage and compute mainly.
Right, but it's not hosted anywhere. You're saying it's kind of distributed.
The orchestrator is hosted as a standalone service right now, but where it's going to head is every validator will have a copy of it, so it will just be integrated into the validator itself.
And if I can get ahead of you, let me guess. The whole idea is that the orchestrator is really the commodity, because if you have the ability to orchestrate the nodes, you can just be like, okay, well, this model will train that one. And you can and potentially you can run multiple models at the same time on the same network with just multiple orchestrators. I see the vision. Is right.
Yeah, what we did in the previous version of Subnet 9, I think we made progress on a couple things. One of them is we had multiple concurrent models that were training. So we had a small model, which was a bit of an on-ramp to miners, the 700 million. We had a 7 billion, a 14 billion. We had a text-to-speech competition. So I feel quite confident that we have a clear path and a track record of we can do multiple competitions at once. I think that's a technical problem that we've already made progress on. And the other one would be a bespoke mixture of data that gives you the best bang for your buck in terms of how much compute you need to get a certain performance out of the model. A lot of these large-scale data sets right now, they're so much better than they were a few years ago because it was just a big dump of the internet with all of the garbage in it. And models learn all kinds of insightful and foul things at the same time, and also just terrible grammar. And of course, there was a big push in data sets, just making them better, because at the end of the day, it's so expensive to train models. If you can get the same performance of a model on a tenth of the data, why would you not? So there's been a massive sort of renaissance in cleaner data sets, and what sort of the common thinking right now in the labs that are training these big models is you need to carefully articulate how much of different categories of data you want to inject during training. So at the beginning, you can teach it to be a bit of a generalist, but at some point, you can give it longer context. You actually train it on much longer sequences of text. It's not necessary at the beginning. It's just learning basic pattern matching. It's overkill, right? You're wasting compute. So you can actually start with quite short, snappy sequences, and then as the model starts to learn to consistently predict 10, 12 words without making an egregious error, you can now say, okay, we're going to do a 1,000-word sequence. And this is actually quite a subtle art. You have to sort of dynamically change the data that flows into the network as the model's training. And we did this. We did this in the last version of Subnet 9 to quite good effect. I mean, we trained some powerful models mainly by virtue of just really carefully controlling the data that went in. So we had some math and some coding data sets, some multilingual data sets, in addition to the big dump of the web, and the results spoke for themselves. So this is something that we have a direct line of sight on right now, and this is, as Will mentioned, this is something that Subnet 13 is going to be supporting Subnet 9 with for the foreseeable future, because it's just such a good fit for the two.
On to Subnet 1, I'd like to query you on that. So Subnet 1, it's like the slot itself is worth like hundreds of thousands of
The
dollars.
holy slot.
Subnet real estate.
Yeah, yes. Free real estate. Yeah, so I think this design is one of the most interesting, and I was just talking to people in the lounge over there about the concept of like a GAN subnet, because it works really well, because if you think about the way that miners work, miners are red teamers, right? They're the adversary, right? They try to break the validation. And in machine learning, there's there's this architecture called a GAN, a generative adversarial neural network, where you have two models, and one model tries to detect the adversary, and the adversary tries to train its way around the detector, and this actually improves the performance of both the detector and the adversary. The bit-tensor subnets have this quality, like inherently we have this, the dark and the light. You guys played this, you'd been focusing for a long time. Subnet 1 has always been focusing on, let's prompt LLMs to produce the best responses to questions. And it's come a long way from just, what's the capital of Texas? And that's an interesting question, as being the answer, to we're going to query them. We're going to create an asymmetry between the validator, who knows a bunch of the answers beforehand, and so they can ask a really hard question to the miners, and the miners can respond, and then you have a reference answer. And so you guys got to this idea of, well, the reference answer itself, the comparison between the reference answer, being the thing that's smart, and the response from the miner is actually a really hard problem. Not only that, but your miners will never get any smarter than your reference answer. But you guys discovered, or you saw in the literature, that there's this really interesting asymmetry in the nature of intelligence, which is that it's test time compute, which means that we iterate for more tokens, we think longer, and the models get smarter. And you can even take a really small model. I think they took like a 2 billion parameter model, and they outcompeted some 30 or 100 billion parameter models just by churning more tokens. And so I understand the design is sort of, you create this reference answer by churning a lot of tokens. You get to this smart thing by going long and deep in a single direction, and then you give it to the miners, and you basically say, hey, generate the same answer, but you only have like 10 seconds to do it or something. And so then you're trying to figure out if they can basically recreate the answer. Is that correct?
Yeah, that's correct. So yeah, to produce a reference answer, we have another orchestrator in Subnet 1, and this orchestrator is like a structured format for thinking effectively. So the validator LLM is it's aware of the tools that it has available to it. Again, it has an abundance of time to perform these tasks. It can actually outsource a lot of its work to the miners because they don't know that they're participating in the creation of the reference answer. This thing is turtles all the way down. So basically, the end result is a painstaking process to produce a very long reference answer. Of course, you can't do this all of the time. This would just stagnate the network and we'd slow down to a halt. So what we do is we spot check periodically. So now what the miner is required, its scoring is basically how convincing of an answer can it produce to the same query that the validator produced that excellent reference answer to, but under very serious time constraints and resource constraints. And that's really the design of it.
So how well are we doing?
Pardon?
How well are we doing?
We're getting better.
That's
No, that's the truthful answer. That's the truthful answer. Look, I'm not satisfied until this thing has really like taken off. What we've seen so far are really promising trends. We've been live for about a month with this design. There were things that miners could do that were maybe in retrospect kind of obvious, but certainly very devious, that we're able to sort of sneak around the game. Like what we want to do is make a zero-sum game. There's no way out of it. Either I win or Jake wins. And we're just going to battle to the death until it's decided. You kind of want that kind of arena for this competition to happen in so that the miners really are forced to improve and they can't take shortcuts. Where we've gotten to right now, I don't know if I've got a percentage for it, but I think the blue and the yellow curves tell the story as faithfully as I could do it. Basically, it started off where it was really easy for the miners that were told that they have to do the guessing part. It was really easy for them to guess, which just meant that the reference answer and the ones that they were comparing it to were very distinct. And I don't know what they did to detect it. I don't own that IP, actually. That just exists on the miner side, right? They came up with some maybe simple heuristic check, maybe a text classifier, whatever it is. But the result was, what was it? 80% of the time, they were winning the game. 50-50 is a sign that you've got a hot battle playing out. And where we reached is we're now hovering around the 50%, which is intriguing. I mean, the game isn't done yet. We have to see what the actual raw outputs look like. We can't just rely on these super high-level charts. We have to look at a lot of things. The cosine similarity, the lower chart, shows that the general the essence of the outputs, although the words are different, are also converging. We're at 92% similarity in the content, which is interesting. But there's a lot of other things that we can do, which we are writing into the paper, which are going to make it much clearer. Like, is the system converging in the way that we want? And we just need to be data scientists about it at this point, and really like be able to look inside the machine and see what's being produced. But
I made him take most of the charts out of the slide deck.
bummer.
I was going to say, maybe the miners did a novelty search and figured it out. It's very possible.
I would love that. I want to be on stage with mine.
So, okay, so then let's say that for all the miners out there, what's the best way to improve if I want to beat out the rest without gaming the system? Is it hardware? Is it software? Is it a combination of both? What do you provide for me as the miner to actually give me a guidepost to improve with?
I think a lot of the time it's working deeply within the incentive function to define your edge. Like, what is the edge? Like, maybe if I use Subnet 13 as an example, because I think Subnet 13 for me with a macrocosmos was my like, oh, incentive mechanisms work. You guys were right. So we set up this incentive mechanism. It's quite simply just give me lots of data. It's not uncapped. It's not go this place and acquire this data and do this. We just spot check data and we do it in a robust way. And when 13 started, I think people were using Apify, which is like an open crawler for X and Reddit, and they were just crawling these things, paying for the license and making enough money to be profitable. And then one guy rolled up who just 100x the amount of data everyone had scraped. And we were like, what? It went from like 1 million rows a day to like 10 million rows a day or 50 million rows a day or something insane. And the guy just posted in the channel and was like, you have to build custom crawlers. The only way is custom crawlers. And people were like, will you tell me? He was like, no, screw you. And then like a couple weeks later, somebody like doubled this. And the only response is, you have to build custom crawlers. And this other guy. So I spoke to a miner who used to mine 13. And he said he bought, I think, 40,000 different accounts an X from someone in Russia that he then parallelized around the world to scrape in an undetectable way, which is like way more complex than the actual incentive mechanism on Subnet 13. And they do all of this work for you. And this is like the unique power. So I think for those miners, they understood we didn't care if it was an API from the X API. As long as you could get that data, it was valuable. And it's the same with getting a loss down. You know, the team who are like, we're just going to rewrite it in C because it will be 14% faster on the communication layer. We're going to co-locate the miners near the validator because we know networking speed is an effect. Like, each different subnet will have an edge. Like subnets like Bitmind, it's about building state-of-the-art AI detection models that are better than you can find on the open market, because otherwise your competitor miner will pick one off the open market and beat you. So it's always about looking deeply to the incentive and how you can win. And you know, look, it's almost a question for Fish or someone else in the ecosystem who's mined extensively, but you just have to be curious is probably the number one thing.
I think if I'm to speak about what it probably takes to do really well in Subnet 1 right now, I could hazard a couple guesses, but I would get schooled if I tried to mine Subnet 1 today. So obviously there's a time pressure, right? There's this massive asymmetry in the amount of time the miners have. So they're going to be looking for the highest tokens per second, wherever they can find them. They may have found ways to work around using the same base model that we do. Maybe they can find a much smaller model or a quantized model, or do some clever optimization so that they get outputs that are very similar to what our more expensive and slower model gets, but in a fraction of the time. So that would be a combination of, you know, more powerful inference using better hardware, but also just doing clever algorithmic tweaks like, you know, reducing the precision of the model and stuff like that. But frankly, I don't know. It's kind of remarkable that something is happening. Yeah.
Have you considered changing the design so that you're not querying the models, the miners, and they don't need to do infrastructure problem? And I think we've talked about this before.
Yeah, we've looked at that a lot.
Going back to the integrations here, is more of a question for Will. Like, what are the active integrations that you're seeing with subnets 13 and 1 and 25?
I mean, with subnet 13, I think there's like 7 or 8 or 9 subnets using it in basic ways. Like for BitTensor ecosystem, we just give them an API key and give them an unlimited rate piece. I know Max and the team were looking at using it on Score to help predict football. I don't fully understand Score, but I think they were looking at social sentiment on player performance for like player purchasing. The guys on Infinite Games are using it to help do edge detection on polymarket bets, I think. I think Gaia were using it as an early prediction trace for predicting weather. So like, as a raw commodity, 13 has like so many use cases. It's also implemented on Shoots on the Squad app, and I think it's one of the most used tools because people are just pulling data, and I've spoken to others in the room about using it. So if you just want to get social media sentiment, understand what Jacob's thinking about, find out what the tweets on this conference are, like you can do all of it through BitTensor. You don't have to go outside, and that's a really unique power. With Subnet 1, we have these research elements, but we also have a series of, we use a task-based architecture where we distribute rewards. So we have this sort of GAN architecture task, we have an inference task, we have the sort of chain of thought tasks, and we also have web search. So in the same way that when you use Claude or OpenAI, it searches the web, it downloads this, it does all of these. This is a native capability in Subnet 1 that other LLM using subnets or tools or apps can access. And again, helps us collectively have the same capabilities as an open lab or closed lab. We're the open lab. So I think the world of subnets integrating is coming closer and closer. I mean, on the first day of IOTA's launch, you got a Celium miner working on IOTA. So like, that's a mining prospect. Rob is asking me when Targon Manifold can mine IOTA, which slightly terrifies me. But like, this is kind of the unique source of everything starting to network together at speed. And, you know, we don't have to go outside of the ecosystem for social media data or more data. You know, we're looking at archive and much richer data sources. We don't have to go outside of the ecosystem for compute, for web search, for chat completion or coding agents. Like, and the more we can, like, there's an expression in tech called dog fooding, where you like use your own tech until it works and it's actually valuable, and you have to eat your own lunch. And you know, our CFO is always telling the team he's going to like shut off all our closed lab AI subscriptions to force people to use our own work, which is a kind of nice way of thinking. Like, we're so much closer to that point than we were a year ago.
I don't think we should be afraid of that. I think we should lean into it. You know, if you have a subnet and somebody is mining it with inferences, let's say, and those inferences are coming from an inference provider like 19 or on Shoots, where we're getting the cheapest inference there is to get. And not only that, but extremely fast. Or it's, you know, you're mining IOTA with Rob's subnet compute. That you should want that to happen, because miner cell pressure is always going to converge towards 100%. And if they can scale more with that 100% by getting cheaper commodities, that's better for you. And definitely in the ramp up phase, there's less cell pressure because they're spending less, and that's all flowing through and staying within inside of the BitTensor ecosystem. The more that we can connect, you know, Will, you've been a proponent of this for a very long time. You know, I think this is really your guys' idea from the beginning with Apex. You were like, we're gonna make the subnet that connects all subnets. That was the idea with Apex, and I think it still is, right? Like, it's a pinnacle element.
That's right. Yeah, I think we've gone back and forth on this idea of the oracle of BitTensor. I think there's technical challenges to doing it. I think once the network and all of the subnets in it reach a certain level of stability, interfacing with them and having maybe some standardized, whether it's an MCP layer or an API layer where the subnets can exchange commodities, is a really exciting possibility. And I think we were too early the first time we tried, to be honest. I think that we were trying to reach out into other subnets, but it was really hard, and we weren't sure the right way to think about it, and how do we have a reliable product built on sort of a tower that's already kind of rocky. But I mean, BitTensor has matured a lot for the last year, and I think now when we were seeing it, I mean, with your own launch a few days ago, we saw something exciting, which is, you know, several Spotlight really scalable subnets are now powering something which is a new next layer subnet, and I've always seen that as an inevitable trajectory for the project.
So in true Novelty Search fashion, we would go to the chat and see if there was questions. Right, we only have like 3 minutes left. Maybe we should go to the crowd, and if there's anybody who wants to put up their hand and ask a question.
Well, because it's a zero-sum game, if you're selected as being a generator and a discriminator, you can just steal from yourself. So it's a futile exercise, and you might as well just not waste the compute. I mean, they can choose to opt out. We usually, you know, we give a large pool of miners the opportunity to participate, and many of them are like, no, I'm good. Because they know that they're on both sides, and actually just sort of self-organize quite nicely. Question. I think what you're describing is like a saturation effect where it just can't get past a certain level. Yeah, I think that's my thinking on it as well. Like, I have pulled my dreads out thinking about how to solve this measurement problem. And I'll be the first to say as well that GANs were an enormous, exciting wave of AI research in 2014 to 2018. And then the world found transformers, and you know, if we can find the transformers for incentive mechanisms, we will work hard to do that. We think GANs it's a big step forward from what we had before that, which was kind of scrappy heuristic similarity metrics. I think GANs is much more principled. It will certainly have its challenges. It will, you know, if it reaches 98% and saturates, I'll slap Will on the back and say, good job, old pal. But I think that this is not over. I think that once we've got this at peak performance, we'll be hungry to take it to the next stage, whatever that design is. I think to Jake's point, GANs do benefit from the fact that you have, you know, it's game theory, and BitTensor is game theory. So there's a native overlap between what is assumed about how a GAN should work and the actions of miners in the network, and you're basically just harnessing that in a really pure way with just kind of getting out of the way of it. You know, as long as you can frame it as like a one-on-one battle between two miners, you get this really interesting dynamic where they just solve it and you can get out of the way.
I think, we sort of came out and said we're focused on research, but I think you can see with a lot of the stuff on Constellation, on Mainframe, other stuff, we're pushing to generate revenue and build tools on top of these research bases. With 13, we originally just imagined it as fuel for training giant models. And there's a way we could go and market that to other labs. But we've built this additional orchestration mechanism on top where you can access it and sell it and buy it for whatever other use case you use. So I think for teams looking at this, you have to look at how can you create utility from your research as you go through that process? We kind of look at it in terms of we're researchers in incentive mechanisms more than AI, and we're using incentive mechanisms to create AI. And as we define these mechanisms and they reach maturity, they can go into production and start creating revenue and become the businesses of the future. And I think that's the mission of the network. I think it's important that we have a research aspect to BitSensor that's solving these big moonshots. Like the Grail moment, somebody was talking the other thing about the sentiment around crypto this summer and we weren't getting a bull run. We need a moment like the DeepSeek moment for OpenAI in Web3. We need something that creates something impossibly powerful that penetrates back into the mind, the corpus of everyone. Everyone's using Tau 1T. IOTA
GPT
1T.
moment is what you're looking for, effectively.
Exactly. And I think that is, it's naive of us to think that comes from focusing solely on productization today. If you go look at the research spend at these major labs, it is colossal. They're always looking for the next thing. So at Macrocosmos, we try to do both. I know many other teams in the ecosystem do. But I think there's a balance between how do we fund it as a network and how do individual companies fund it. But Jake, I don't know if you have a view.
I disagree. I think that there's pure play commodities subnets that make a lot of sense and are really optimizing margins. Like if you're doing something kind of unsexy, I mean it's hard, but like aggregating compute or doing deterministic inference, right? Like there's not that much innovation. To some degree, we've really collapsed that down, and now it's like a margins game. It's getting really, really commoditized. We've achieved our aim for those things like compute and storage and data collection. Data collection is, I think, a pure commodity play. But then there's what we've seen in venture capital is that there's another type of company that is playing a different curve. And we know that there are these like far out plays with the first subnet to really crack decentralized training in a scalable way where we can say, oh, holy shit, this properly co-locates all the compute on top of BitTensor, and we have all the compute available, and that's just spinning, and we can get that the cheapest, and so we can just go and be bigger, like 10 times bigger than a lab. That moment's going to happen. It's an inflection point, but so maybe Templar's not there, maybe IOTA's not there, but you guys are iterating fast. You don't need to make money right now, but as soon as you are at that point, it's pretty clear that if we have the largest models, if we have the best models, that's something that we can capture and give back to token holders and distribute and decentralize and make open source and make it good for the world. So people can play that style. They can also play the pure margin plays. JJ is doing with Tau Hash core pure margin play, very, very, very pure play on BitTensor. It's good that we have both. We're gonna like build up on them, all the way to the top. So I don't think we should be discouraging people from doing these type of more, like high ideal, far out plays. I think that the incentive is there. I think that the network is interested in stimulating that, and we should definitely have that all over the place.
I think it was a big fear before DTAO that it was all going to be products and margin and commodities and that other point. And I think that there's an immense amount of interest in research on that moonshot in the network. And I think it's another really promising aspect of DTAO that it has continued to fund projects like that, including ours.
And also can be interested with subnets, like will people be able to, have a research arm of their own subnet? This is something that we want to see, and it's definitely how Google did it, right? They have their pure margins play, and then they have something else. And so we're definitely going to see sub-economies grow with inside subnets. And that will definitely, certainly allow that behavior. Cool, guys.
I see there's one caveat to what you said, Jake, and to what you said, Will. in effect, a lot of these labs can actually get away with doing nothing, right? Like a lot of teams at Microsoft Research, a lot of teams at Google Research, they don't really produce much except for becoming paper mills. The nice thing about detail, nice thing about BitTensor is that there's always expected results. Even if you're a research lab on top of this, and that's totally fine. You have to show what you've been doing. If you've been doing anything, you get disincentivized. So I think that's kind of the biggest point here, is that sort of productivity is very, very encouraged, and it's actually almost like producer perish effectively.
Again, Rob? That doesn't matter. There was a question here. No, I wouldn't. So you said, is the holy grail the fact that a desktop can contribute?
No. Large-scale parallel pipeline training, like, can consumer compute layers be competitive? And the answer is no, not on their own. There might be an interesting behavior where you have mining pool aggregators. This is what we're looking at. So maybe every consumer compute in the room could be competitive on rewards, but you're not going to beat a networked data center of Blackwell chips. But the point isn't necessarily to be the top miner in that scenario. It's to distribute rewards for compute that's not being utilized. So it's an additional edge to help aggregate more compute. Jacob's wincing, so maybe disagrees.
No, I wasn't.
But there you go. But I think, you shouldn't expect to be top miner on your Lenovo machine. I mean, you should never expect to be top anything on your Lenovo machine at home.
Yeah.
But like right now, a sort of a MacBook 128 gig, the sort of like researcher level machines would, like, in today's epoch, be gaining incentive. And if you can run it in the background while you're not doing anything else and it's sat at home, we will happily burn through your GPUs for you. But I think it is interesting as a way of helping make BitTensor and training much more accessible to everyone in the room. Like, if you could train at home, part own this model, become a holder of these things, it makes it much more real to you.
Yeah, I think it's much easier to decentralize the ownership than it is, especially in this particular subnet, the decentralization towards a laptop like my MacBook. When you're doing pipeline parallelism, I'm going to be running some layer. I need to aggregate that layer with all the other nodes. We have to do an all reduce, and that scales in the number of nodes. So if there's 100,000 MacBooks, each of those MacBooks doesn't bring very much, but it definitely forces that all reduce to be more expensive. So there tends to be a convergence toward, like, centralized compute with training, but we're now at a point where, like, a fair amount of decentralization is possible because we have better algorithms, but it's not MacBooks. It's more like someone has a 8x H200 box over there, some island of compute, some GPU, and, like, that's a big enough amount of compute to be monetizable inside of a subnet. When you add these layers of markets, on top of BitTensor subnets, very quickly you recognize that people are pretty freaking serious, right? So you're bringing a MacBook, you want to contribute, right? And then the guy beside you is like, well, I'm going to bring 500 MacBooks, right? And like, monopolies form very quickly. And if we're really serious about pushing the state of the art, we have to just lean into that. We have to lean into, let's make these things as efficient as possible, but build the incentive mechanism so we can aggregate more compute. Like, we have now decentralized compute on BitTensor, which is perfect. It's a perfect customer for decentralized training, right? Or decentralized training is a perfect customer for decentralized compute. And so it starts to make sense when we have, cheap distributed compute, and then we can now the algorithms that can co-locate and connect that cheap distributed compute and make things which are more efficient than even the largest supercomputers in the world. And even those companies are starting to study distributed training because they know that they themselves don't have all of their GPUs in one place. So like the field is there at this point where, you know, I think that we're definitely going to scale. But yeah, no, I think it's kind of the whole MacBook thing is no.
I think to add my bit to this,
Not for that problem at least.
The important thing to pay attention is you can look at like the minimum entry requirement, which is the MacBook argument, but you could also look at if you don't have something like pipeline parallelism and a way to shard a model into small pieces, then the network can't grow bigger than its smallest node. Right? So there's just a scaling problem, a fundamental scaling problem. And pipeline parallelism, whether the nodes are big or small, it's kind of immaterial. I agree with you. Like, let the market decide, to be honest. I don't want to worry about the economics. If you have a huge network of tiny nodes, you do have to pay a price in the time it takes to transfer the data to those nodes. And if they're not producing much valuable compute after receiving all of that data, then there's an argument to be made that it wasn't the best use of the network's capacity. But what you don't want to be stuck with is we just can't train a bigger model than this until I can get this entire group of peers to run an 8-box or something like that. That's where it feels like it's much more brittle, and you need to break beyond that.
Mm-hmm. But I think it's possible. It's very possible that in near future, you guys structure the incentives, the economics here, where you have somebody brings 10,000 nodes and brings a MacBook, and they can work in their way. And I think that's really the goal here is to build those algorithms. So we're way over time. So I think maybe we should stop there. It was a lovely presentation, guys. It was so good to do Novelty Search in the flesh.
In the Louvre.
In the Louvre. In the flesh.
Long ways.
Thank you, guys.